Hello, I am Tiberius, and firstly, thank you very much to DarkCon for inviting me to speak. As some of you might be aware, I know a thing or two about privilege escalation, so for this talk, I'll be covering a few weird privilege escalation techniques. I guess the first thing I should do is define weird. Google gave me this definition, like very strange or unusual and difficult to explain, which I think is pretty good. I'll be focusing on 4 privilege escalation methods, 2 from Linux, 2 from Windows, all of which I would say are strange or unusual, but hopefully not too difficult to explain. I'm a great believer in learning by doing, and also that practice makes perfect. So everything I'm going to show you today, you can go try for yourself by signing up for a free account on TryHackMe. You do not need a paid subscription at all. The 2 room URLs shown on the screen are available to everyone, and they also have a load more privilege escalation techniques that you can try out too. So let's start off by talking about bash globbing. On Linux systems, if you run the command ls, you get a list of the files in the current directory. That's pretty simple. But if you run ls with an asterisk, you get the same result. What's happening here? Does the ls command ignore the asterisk, or does it parse it somehow? Well, interestingly, if we run the echo command with an asterisk, we get the same result again. This is a big clue to what is going on, because echo is just used to, well, echo whatever you tell it back. So this is actually bash causing this. When you type an asterisk in a bash prompt, bash is going to take that asterisk and effectively replace it with a space-separated list of the names of the non-hidden files in the current directory. And after it's done that, it just runs whatever command you typed. So in the previous example, what we typed was ls followed by an asterisk, but the command that actually got executed was ls followed by a list of the files in the directory. And when you give ls a list of file names as arguments, it's just going to return them. This is known as bash globbing, also file name expansion, and it doesn't stop at a single asterisk. You can create some rather complex regex looking patterns like this one. This one will match only 1.txt and 2.txt and leave off 3.txt. And you can probably see why. If you've ever played around with regex, it's kind of obvious. So you're probably wondering, how does this relate to privilege escalation? But to fully answer that, you have to understand 2 more things. The first thing is that commands really don't know the context of any arguments that bash passes to them, i.e. whether they are typed explicitly by the user or generated from file name expansion. The second thing you need to know is that Linux file systems have hardly any restrictions on file names. For example, --foo and --foo equals bar are both valid file names. So this leads to the question, what happens if we create a file called --help and run ls asterisk? Let's try it. So I am logged on to a Debian system as a low privileged user account. Let's create --help. We can do this pretty easily using the touch command /--help. If I just type ls, there it is. So if I type ls asterisk, what happens is we get the ls help text, right? And that's because when we typed ls asterisk, bash interpreted the asterisk as this list of files, which means that when we ran ls, --help was the first thing after it, which obviously creates this help text. Okay, so let's remove --help so it doesn't screw up anything else. How can we use this to privilege escalate? Well, if we look at the system-wide cron tab, we see that the root user is running this script every minute. And if we see what this script does, it cds into our user's home directory, and it runs the tar command to back up all the files, and it passes the asterisk as a wildcard. So if we go to GTFO bins, which is a great site that has a list of all the ways you can really bypass security restrictions on Linux binaries, or Unix binaries really. If we search tar and click here, we can see that tar has these things called checkpoints, and you can run your own code here. So what this does, that if a checkpoint's set to 1, it means that the checkpoint action will be executed every one file, right, that tar processes. So we can use this to create a script and tell tar to execute it every time a file is processed. So we're back in our home directory. I'm going to create the file PrivEsc.sh. We're going to make it a bash script. And what we're going to do, because this is running as root, we're going to copy bin bash to the temp directory as root bash. And then we're going to use the chmod command to give temp root bash SUID. It's going to set the SUID bit, which means when it executes, it's going to execute as root because it's a root-owned file. So if we save that and make that script executable, now what we need to do is create a file --checkpoint equals 1 and a file --checkpoint -action equals exec equals, and then the name of our script. So let's do that. Firstly, we'll copy this. We can do it all in one command. So we'll paste that, and then we'll copy this bit all the way up to the equals, and then we'll do // and then we'll type PrivEsc.sh because that's the command we want to execute. And if we now type ls, we see we have those two commands and the PrivEsc script. And let's check what time we are. It looks like we timed it pretty well, so we've got 3 seconds to wait. If I do an ls/temp now, we have root bash here. It was created, I think, yeah, just a few seconds ago. So now what we can do is we can run root bash. And remember, if you aren't familiar with doing an SUID version of bash, to get it to actually execute with root permissions and not downgrade you, you need to use -p. And so you can see if I type ID, we are actually, our effective UID is set to root, or I can just type who am I, and we are root. The second weird Linux PrivEsc I'll be covering is a writable /etc/password file. This file is usually world readable, and that's fine. It contains useful information relating to users on the system. However, the file has a dark history in Unix, and originally it stored the hashed password of each user as well. Obviously, having read access to password hashes is bad, so eventually the hashes were moved to /etc/shadow, which is only readable by root. Here's an example line from /etc/password showing information about the root user. The fields are all separated by colons, so the first is just the username, the third and fourth are the UID and the primary group ID, respectively. Then we have the general information field, the user's home directory, and which login shell they use. Now, I purposefully skipped over the second field, though. That is where the password hash used to be stored. On all modern Unix-based systems, including Linux, that field will just contain an X, which effectively means that the hash is stored in the shadow file. However, most systems still support password hashes being stored there, and since the password file gets checked before shadow, if you have write access to etc password, you can generate a password hash, update the field, and use that password to authenticate as that user. Things don't stop there though, because if you simply leave the field blank, some systems will take that to mean that the user has no password at all, and you can simply switch to that user without having to type anything else. Of course, overwriting the root user's password or making it blank is a huge no-no in a real engagement, so my recommended way of exploiting this is to take advantage of user aliases. We talk about users in terms of usernames, but on Linux, really the only thing that matters or should matter is the UID of the user. Remember, the UID is the third field in the user's entry, so root's UID is 0. However, to add to the weirdness, you can have multiple users with the same UID, provided the username is different. I call this an alias. I'm not actually sure if it's got an official name. Either way, if we have write access to etc password, we can just create ourselves a brand new user who, for all intents and purposes, is the root user, just with a different name. I tend to use new root. You'll note that the only thing I've changed is the username, and then you can do whatever you want with the second field. I recommend setting a password, especially if you're doing this in a real-world environment, but the same trick with no password can sometimes work as well. So let's check this out. We are back on Debian as our low-privileged user account. Let's check the permissions of the etc password file. And as you can see, it's still owned by root, but it is writable by everyone, which means we can just edit the file. We'll go to the very end and paste in our new root user account with the password hash of password. Everything else the same. This is basically a copy of the first line, just with the username changed and obviously the new password. And then we can save that. And then to switch the user, we use the switch user command, or su, and type new root. It's going to prompt for the password, which we know is just password. Press enter, and as you can see, we aren't new root, we are root, right? If I type ID, it says we're root. If I type who am I, it says we are root. And so we just privilege escalated by creating a user alias of root. Moving on to Windows now, the first weird privilege escalation technique here deals with unquoted service paths. So services in Windows have a bin path or binary path, which contains the command that the service runs when it starts up. Here's a quick example. If we use the sc utility to display the config of a service, among other information, there's the binary path name field, which in this case shows the command completely unquoted. Here's the same command, but with proper quotes. When configuring the service, if the bin path is surrounded by quotes, Windows knows to interpret the entire path literally. Weird stuff can start happening if you don't use quotes though, and it's due to the way Windows interprets commands. Executables in Windows usually have the .exe file extension, but you can type just the file name without the extension and Windows will still run it. This is why whoami and ipconfig both work, right? Both are actually .exes located in C Windows System 32. However, executables can take arguments, generally separated by spaces, and executables themselves can be referenced using their absolute path as well. And paths can also have spaces in them. So hopefully some of you may be seeing the problem, right? Consider running the following unquoted command. C, program files, some directory, some program.exe. To us, this looks like we're just running some program.exe, right? It's pretty obvious. But to Windows, this could be one of 3 potential commands. To more easily show how Windows tries interpreting this, I'm going to display what Windows thinks is the executable in green and what it thinks might be arguments in red. So firstly, it sees the space after program and thinks, okay, maybe program.exe is the executable, and there are 2 arguments, files \some and directory \some program.exe. Secondly, it sees the space after some and thinks, okay, well maybe some.exe is the executable, and there is only 1 argument, directory \some program.exe. And finally, as a last resort, it will consider the full command as it was originally written. What makes this exploitable as a privilege escalation is Windows tries executing these in this order until it finds one that works. So if you have permission to create program.exe or sum.exe, you can create your own executable which will run when the service starts. So I am connected to the Windows machine as the low privileged user account. And if we use sc to query the unquoted svc service, we can see the binary path name is indeed unquoted and it has some spaces. So what we need to do now is determine whether our user can create program.exe in the C drive, or unquoted.exe in the program files directory, or common.exe in the unquoted path service directory. And what we're going to use to do that is icacls. This command will just basically, if we give it a file path, so C, it'll tell us which users or groups have access and what kind of access. So the users group, which we're a member of, doesn't really have write access here. If we try for program files, again, our users don't have write access. So let's try that unquoted path service directory. And this time, the built-in users group has full access to this directory. So that means we can create files. So if we scroll up, we have access to this directory. So we need to create common.exe. And I've already created, you can see it on the desktop here, reverse.exe, which should just connect back to my Kali box. I just did that to keep things easy. So what we'll do is we'll copy that. I should spell copy correctly. Copy that from my desktop to C program files unquoted path service common.exe. Okay, one file copied, perfect. Now what I want to do is I'm just going to switch back to Kali and we're going to create a listener on port 53. That's what I'm connecting back to. And finally, we need to start the service, and we can just do this with net start unquoted svc. And if we start that, you see we did get a shell back. And who are we running as? We're running as system, which is exactly who we should have been running as. So if we scroll up, we see that the service start name was local systems. This is who the service runs as. So that's how we privilege escalated, by effectively abusing this unquoted binary path name. The final weird privilege escalation technique I'll be covering is really just abusing the Windows GUI. Sometimes you'll encounter an environment where a GUI app will be running with admin privileges for whatever reason, and of course, if we can spawn a shell from this app, it will inherit those admin privileges. That's expected. What I find weird about Windows in this respect is that it's really easy to run programs using the standard dialog boxes, save, open, etc. If you've ever tested older Citrix environments, you'll know what I mean. But let's try it out. Okay, I am logged back onto Windows as the low privileged user account. And you can see on my desktop, I have this admin paint shortcut. If I double click that, it opens up Paint. But if we go to the Task Manager and we select Paint, right click, go to Details, it highlights it down here. We can see it's actually running as the admin user. So I've configured this in such a way it starts as admin. So what we can do is if we go to the File menu and click Open, you can also do this with Save. Generally speaking, so this is used to open files, right? But if you just click up here and type, for instance, C Windows System32 cmd.exe and don't press open because that'll actually try and open it, but press enter instead while the cursor's there, it actually spawns a command prompt. And if we type who am I, you can see we are running as admin. So now we have admin privileges from a command prompt and can execute commands. So the same thing works with the save. So we can just go up here again, C, Windows, System32, cmd.exe, press enter, and it'll spawn that. And there's a few ways to get this, but effectively you can do it via this dialog. So that's just a weird quirk of Windows, the fact you can launch things from open or save dialog boxes. Thanks so much for watching my talk. I have a few social media links on the screen. I'm pretty active on Twitter, occasionally stream on Twitch, and trying to create some more YouTube content as well. I also have my own Discord server, or you can just add me as a friend directly. I love speaking to people about this kind of stuff, so please do reach out if you have any questions, and I'll do my best to answer them.